Okay.
What? But I feel like I would also learn.
She did.
I wonder if oh yeah?
Okay, what's the next one? Besides predator avoidance?
Maybe it's a ritual that they do before migration.
Okay, good. First of all, I also, let's see. Someone said communication.
To find food.
Mm-hmm. Oh, that's what it is. God, why isn't it letting me do this? Come on. What?
What app is that you're using?
Everything. Explain everything.
I've never tried it, but I've seen other people. It's really cool.
There we go, finally. Okay. Someone said, what is it, migration?
Yeah, a ritual they do before migration.
Okay. Let's see, there was another one. Hunting. Okay. Any more?
Maybe some kind of meeting ritual.
Okay. Okay. Good. So, the question is, how would we test, let's say, the keep cool hypothesis? This takes observation.
See if they do very similar behavior not over the water.
Okay, not over water. So you're saying, what's the difference between the over water and over water?
Well, he was saying that
They keep cool.
he said, yeah, but he said like over the water, keep cool.
Okay, well, so, in other words, so maybe over the water it's cooler.
Yeah.
Okay.
Or maybe they like go into the water or
Mm-hmm, okay. They also, it turns out, do this in really hot places too. Okay? So, the prediction would be that if it's really to keep cool, that it would only be when they're frozen, cold, right? Or no, I mean when it's hot. Sorry, that's right. The other way around. So they do it no matter when it's cold or hot. In fact, up there, that's Humboldt County.
Yeah, that was pretty cool.
It's actually winter up there, so it's cool. It's not terribly cool, but cool enough. Okay. Predator avoidance. How would you test that? Okay, you could take away predators.
Try to observe to see if the predator's actually around while they're doing
Mm-hmm.
display.
Right. Okay, that's good. Anything else that you might do? Remember, we want to try to actually,
Bring in the predators.
yeah, we want to disprove the predator avoidance hypothesis. So, how would we? It's hard to do a field experiment. It's pretty much observational.
Well, what if there was like a flock of birds that were just like hanging out,
Mm-hmm.
brought in a predator and see if they did it?
Yeah. Okay.
It'd be pretty messed up.
Good. Excellent. Yeah. It turns out this is a mixed flock of seabirds, shorebirds, like different sandpipers and whimperls and all sorts of different things. And they all hang out together, obviously on that rock. It seems like it's probably safer there, perhaps. This kind of behavior is found all over the place too. So it doesn't really matter whether, it can happen anywhere. So what you said, the prediction is that when predators are in the area, you'd expect them to do it more often. So you do an observational study and take as many individual measurements as possible. Like you go down there once a day, you see them do this behavior, do you see any predators or not? And then also, to get a little bit cleaner on it, they're all sitting there on this rock and you see like a peregrine falcon come in, and what happens, right? So this is kind of correlational, but it gives you some predictions that perhaps support that. If it was an anti-predator behavior, how are they accomplishing this?
They look bigger.
Mm-hmm. They look bigger. Anything else?
They could, should I talk or something?
What?
Should I say something or should I listen?
Go ahead.
They could, if a predator is coming towards them, they could all split up at the same time, and it would make it harder for the predator to decide who to go after.
Okay, so do they split up or do they stay together?
I mean, if a predator,
Yeah.
I didn't see any of predators.
Let's say
there,
a predator shows up.
they would split up under that theory.
In other words, each individual would go their own way.
Right.
Okay, good. Anything else? Would they, what do fish do when they school?
They stay in a really tight knit group.
Mm-hmm.
And if predators do come, they still stay in that area. But if whenever say dolphins come through,
Yeah.
they split into two groups and
Mhm.
then swim back around and then they come into their
Okay.
shape again.
Okay, and so but there's still groups, right? Okay.
There's not really any individuals.
Right, yeah, and they stay in a tight formation when they're changing, just like these shorebirds do, as a matter of fact. How do you think they stay in such a tight formation? Is there a leader, do you think? Okay, perhaps. Is there not a leader? Could you get this behavior without a leader? No. Okay. Anybody think that maybe you could get this behavior without a leader? And how might it happen?
I think it's kind of like working together, like they all know what.
Okay. So this is a working together, cooperative hypothesis. Okay. So you don't need an individual leader, but everybody's kind of like a group mind.
Kind of like, this is going with the predator avoidance. If like an individual is on its own, it's not as safe as like if you're within a group. So
They get a, right, in other words, so the predator, instead of splitting up, they stay together. And that's actually prevents a predator from going after them, because they're all in this group and flashing and all that, right?
Yeah.
Okay. Can you think of any mechanical way that they would not do it necessarily for cooperation? In other words, they're not really thinking about we have to cooperate here. They can maintain this kind of cohesive flock, just because of the properties of the flock. So think about if you're in a flock and you're surrounded by others, and they make shifting changes, like split second, faster than you could actually think about it. Okay? And they all do it in the same place. How would they actually accomplish that? Have you ever seen, the V formation with geese? Okay. Why do you have one in the front and then all these guys in the behind, kind of offset? What do you think they're doing there?
Is it for like aerodynamics?
Yeah. In what way?
They use less energy.
Less energy. Okay. And it turns out, when young geese, they're not so good at it, but they learn, and they don't learn, they learn by trial and error, or a little bit more than that. They feel change. It's like trailing a semi. So you've got this wind shadow, right? And you're having to spend less energy flapping. Hi. And just the littlest bit is less resistance than a little bit more. And that's what actually affects where they situate themselves. And so individuals now, the poor bum who's up at the front isn't getting the effect. So I forget how that works. But anyway, now in this flock thing, can you think of a similar mechanism where they feel all these other birds around them, and the slightest difference, they all go with it. And that's actually how they do it. Okay? So it doesn't require cooperation or thinking or anything like that. It's just a strictly physical movement. Now, of course, they know that there's a predator about, or they think they do. They're very skittish, by the way. The littlest thing can get them all riled up. Okay, so with the predator avoidance hypothesis, they're all in this group. Do you think it's difficult or easy to single out one individual in a group like that, that's flashing and all that, versus one by itself? Okay, so no. And it turns out that's true. So, oh yeah, let's say it was actually cooperative. So, would you do it with a bunch of close kin or not? That'd be one reason. Okay, these guys, of course, obviously they're not related because it's not only not the same, relatives, but also different species. remember the zebra tail lizards from this weekend? When they run, they hold the tail up in the air. Why? Remember?
So it doesn't drag on the.
No? What?
Other stuff.
Defense against what?
And communication for other lizards.
Uh-huh, right. So it's like, go after my, or no, it's actually like it might be a signal.
Yeah, so the other ones.
Yeah, say, I already see you, so don't even try to chase me, you're just gonna waste your energy. Okay. Zebras, if you notice, have the same sort of coloring. They're also usually social animals. And there appears to be a predator avoidance thing with that. So, often what you do see when you see this behavior is you suddenly realize that there's a peregrine falcon or a merlin right in the midst of them. And they're all staying together in a cohesive unit, flashing and all that. The predator is actually, well, usually you think would get distracted, and actually does in a group. In fact, the whole hunting strategy of like a peregrine falcon is to get one individual away from the rest of the flock. The thing is, it's hard to get one individual because there's all these other signal coming in from other birds, but that's the idea. So it actually is a predator avoidance hypothesis. In a way, it is a communication hypothesis. Well, what are they communicating about?
Danger.
Yeah, danger. And then there's that physical thing of staying in a flock. That's a form of communication as well. Migration, in fact, they do all get into a flock and migrate at the same time. The only difference is they don't show this kind of visual distortion that you would, in fact, most of the times they're actually flying at night, migrating at night. So, and then hunting, okay. Shorebirds, what do they think they eat?
Fish.
Fish? Okay.
Sand crabs?
Huh?
Sand crabs?
Sand crabs? How come they have all these different sized beaks?
To get different food.
Different food. Okay, so some of the food might be deeper, some more shallow. Some might be kind of in crags and rocks, in a tidal zone, that sort of thing. So, but when they're doing that, do you think they're flying around trying to catch stuff, or do you think when they actually try to eat something, they're sitting there and trying to forage? Yeah. So, they don't do it really for hunting. Mating. Well, they don't. They don't really do it for mating. Mostly what happens is, of course, the males display. They go through two different plumages. There's the basic plumage where they all kind of look the same. And then there's the alternate, what's called the alternate plumage, where the males get, all gussied up. And then it's a matter of mate choice and male-male competition going on. Interestingly, one of the shorebird groups actually, or a couple of them, do sex role reversal, where the female is actually competing for the male. So what she does is the males each make a nest, and the female, if she chooses them, she lays an egg or two in the nest. So she can have multiple nests going on at the same time. And there's a bunch of first of all, she can also store sperm. So although the males think it's their offspring, it doesn't necessarily be. A lot of times it's a surrogate. You know, and there's only one male that she knows this is a good male to do it with. So, okay. And of course the males, since they're the choosy ones, they're going to be putting parental care into the offspring, right? They have to, they're choosy. They don't want just some old egg in there. They want first grade. At the same time, the female is manipulating the males into thinking, you know, she gives them copulations, that sort of stuff, so everything's good. Until they do a paternity test. Which they do. In fact, that's how they found out.
I have a question about that.
Yeah?
So, you know how like in the book it talks about animals preferring to help their own relatives,
Mhm.
right? So how do they know it's their own relative?
How do you know it's your own relative?
You grew up with them, or you're told.
Yeah, you grew up with them, right?
Right.
They're not like, you don't recognize them. In fact, you do.
Right.
Okay, so it's the same sort of thing.
But then like with, could be like a neighboring tree.
Yeah.
Like birds that they see pretty often. That
Yeah.
doesn't necessarily mean it's their relative.
Yeah.
Is there like something like?
So, what they've established is that, yes, they're aware that they're surrounded by relatives. The question is, how do they know that?
Okay, which one is relative? And
Yeah.
Which one isn't?
And you would think that it would be just growing up in certain circumstances, but there might be something else going on there, and I'm not sure what the mechanism is.
Because I was thinking, if there is something else going on,
Mm-hmm.
then why wouldn't the father know that the offspring isn't his
Mm-hmm.
in the situation that you just laid out?
Right, yeah. Because perhaps when the eggs hatch and the chicks, maybe they don't smell right, something like that.
Right.
Apparently,
They're fooled.
they're fooled. Okay. Copulations do that with males. They think everything's all fine.
What was the bird again? What was this?
Okay,
bird
so
talking about? The one that does this, where the males are choosier.
Yeah. Phalaropes. A couple of different kinds. Okay. Okay, we went all through this previously. Hold on a second. Let me see something. Okay, there we go. Okay, hopefully I got all that other stuff. So, does mobbing behavior distract predators? Do you know what mobbing is? Okay. Okay, so that gets you the idea of what mobbing behavior is. Why are they mobbing the cranes? What are the cranes going to do? Yeah, steal their eggs. So, the question is, why are they doing it? So let's come up with some different hypotheses about perhaps why there's actually mobbing behavior. Hold on a second. Okay. Let's see. Okay, there we go.
Start over.
Yeah. Okay. So, so the benefit experienced, in other words, here we have probability that a crow will be subject to greater than 10 attacks by gulls per minute, and then this is percentage of successful predation attempts. So, when they're inside the colony, let's see, which is which? Oh, that's right. So the red is, okay, the red is probability of the subject will be attacked. So inside the colony, there's greater attacks, border, less so, and then outside the colony, not so much. And then percentage of successful predation attempts. So when they're outside the colony, there's more predators trying to do it. It's easier to go after the nest of one individual than the others all mobbing you. So there's support for this. And they get greater response to predators the closer they are to the colony, even though the colony is not made up of kin. You don't need that for this to happen. Okay. Oh, this is a different one. So there's a snake there. Why are they doing this? Why is it doing that?
To shoo it away.
He's trying to be aggressive or something.
Why doesn't he just run? I don't
It's
understand.
not really working.
Well, he's certainly kicking sand in his face.
Why doesn't he just run away like he does here on campus? Oh, good. They just,
So why don't they run away?
yeah, I don't get it.
What is it? Did you say? Oh, anybody? Why don't they run away?
It's trying to protect something.
What are they protecting?
Young.
Young. Good. Okay. Hmm?
So wants to get eaten.
These guys. Wouldn't they get eaten? Yeah. It's a good question.
That's so sad.
Okay. So. Now we know that mongooses harass cobras. In fact, they actually try to eat them. So there's two hypotheses. It might be that this squirrel is actually trying to eat the snake. And the other is that it's young.
Could be a third hypothesis.
There can be many. Any others?
I kind of often wonder if it could, I mean, obviously that's squirrel number 15, right?
Yeah.
So if they're observing several squirrels, right?
Yeah.
If they find that only 1 out of 100 is doing it, it could just be a thrill-seeking squirrel.
Mm-hmm. Okay. Or not necessarily thrilled. He just gets pissed off.
Which
You
is
know,
kind of like humans, right?
yeah.
Some humans like to swim with sharks. for
Oh yeah,
example,
that's
right?
true. but it's also, it's just that this guy pisses me off. Why is he here? I'm gonna,
Right, it's just like,
Yeah.
just not being the kind of the outsider
Mhm.
of the group. I think that's kind of the problem with when we do animal behavior is we assume that they all act
the same way.
the same way.
For the
but
sa-
there's-
yeah.
They're different individuals with different personalities,
That's
right?
true, absolutely. In fact, animal personalities is a big hot topic in behavior now. So, oftentimes what you do is you actually get, okay, enough.
So are the squirrels trying to bite the snake or just intimidate the snake? 'Cause it
Oh,
doesn't
I
seem
think they probably could take nips if they can get a handle on it.
Okay.
They often do this when they have, all their young are underground in their burrows, and they kind of escort the snake away from the burrow. They'll still do it by themselves, doesn't matter. But what usually happens is if one starts and finds a snake, everybody knows within a short period of time. Okay, so remember with the zebra tail, they hold the tail up. What kind of a signal? That's a pretty, visual signal, isn't it? Do you think it might ever be used to distract the predator? Like, go try to get me, and they go for the tail instead of the rest of the body, right? Well, all this tail movement they're doing, especially when they're dealing with pit. You guys remember what a pit viper is? Rattlesnakes are pit vipers. What kind of information does it give them?
Sensory
How-
or heat?
Heat. Exactly. It turns out that not only is the tail a big visual signal, but they can, while this is going on, blood supply is actually diverted to the tail to actually kind of make it hotter. So it's a distraction for the snake in terms of an actual target. And then finally, so we have ground squirrels all around here. You can find ground squirrels, different species, whatever, with in areas where there's no snakes versus areas where there are snakes. And they found that the adults are immune to snake bite. Like a dose that would really make you sick, land you in the hospital, nothing happens. They also found that in areas where there are no snakes, when they're dosed with, snake venom, they die. It also turns out that the young are up to a certain age are also susceptible to the venom. So pretty much these snakes are going after young. They can't go after adults because the venom really doesn't work. So you get this. Also, obviously, if there's no snakes around, how do you think individuals know that a snake is dangerous?
Individual squirrels?
Yeah. So where there's no snakes around, would they recognize that a snake is dangerous, do you think? Versus when they're living in an area, they were born in an area where there's snakes, do you think they would recognize?
They may not.
They may not. So that would suggest what? Learning behavior, right? Now, I don't know exactly if it's true or not, but remember I talked to you about the monkeys and the snakes, and it's actually a combination of both. It might be that a snake is an inherited cue, but it's only turned on in a group where everybody's responding to it. So I'm not exactly sure what's going on, but that's the general gist of it. Okay, good. Okay, so in terms of hypotheses, like I said, we came up with like what, 6 different ones for the shorebirds? Those are alternative hypotheses. So instead of just testing one hypothesis at a time against the null, which is, the null is there's no effect, essentially. So if it was not the predator hypothesis with the shorebirds, then they would do this behavior all the time, whether a predator is there or not. And versus with a predator, they might do it a lot because they're skittish, but they would more likely to do it when a predator is there. Okay, so one of the better ways to often do things like this is to come up with a whole bunch of alternatives that make different predictions. So when you were doing the stuff with the digger wasps, those in the field class, there were a whole bunch of different hypotheses. I think there were 3 of them, essentially. But you can come up with a whole bunch of hypotheses. So, of course, if we're an adaptationist, which is an individual who thinks that everything is adaptive in terms of evolution, then we formulate alternative hypotheses. They make predictions, we test them. Are different hypotheses and their predictions mutually exclusive? Not necessarily. So you can have both things happening, both causes operating at the same time. Okay. The way we finally find out, let's say, what is the best explanation is we try to refute it, in other words, falsifiable, and if we're not able to refute it, there's kind of conditional acceptance until new information comes along. So does that mean we should stop here? No, not really. Do we have an answer? We have a possible good answer, and it may hold up over time. Now the question is every explanation, every hypothesis adaptive? Can you think of a situation where it's not adaptive? Think about evolutionary history. In the past, the ancestor, this kind of behavior it was originally adapted for this response. What if this response is no longer around? I mean, the reason for it is no longer around. With the current species that make up this group, or taxa, would they all still do this behavior as a holdover from what happened in the past? So you have to make kind of distinctions. Sometimes it's just the result of it. Now, there could also be the same thing in the past was going on, the same thing in the future is going, and right now is going on, and so there's current selection as well as what happened in the past. But a lot of there's a guy named Stephen Jay Gould. You might have heard of him. He's a paleontologist. He was kind of pissed off at everybody for saying everything was adaptive, and that if one adaptive hypothesis wasn't good, then you go immediately to another. So there was an archaeologist who worked in Mesoamerica, looked at the Aztecs. Now, the Aztecs, we're going to let you go, but the Aztecs, of course, made lots of sacrificial victims, right? And so there were questions about why they did this. And to make a long story short, this guy came up with a hypothesis that there wasn't enough meat. You know, so how do you get meat? You go find other groups of people and you butcher them. Yeah. It turns out, well, that really wasn't the reason they were doing it. It was a whole cosmological reason, you know. I mean, usually that's why you find, like, let's say one religion. But anyway, that's good for now.
So, do you have the keys to the Highlander?
Oh, all taken care of.
Oh, it is?
Yeah. All we had to do is they'll watch it themselves. I'll take it over to, and we don't have to do it by our hand. We do it with a car.
Okay.
Okay?
It says,
Yeah, that's done. Yeah. Yeah. So but we do have to watch all the other stuff. So I have to call. What is that? What? Oh.
Thank
yeah. Sorry.
Uh-huh. Oh, yeah.
Oh my god, there was one on my door last night. I couldn't go in the house. I looked the other way. It was right by my front door. I'm like, I'm not going this way.
Number 3.